So the first thing we're going to ask ourselves is, what is a unit rate? To do that, we need to distinguish what a rate is. So a rate is a ratio, but it's a ratio in which the two quantities that you're comparing have different units. So the units have to be stated in most cases to avoid confusion. So for example, if a trip of 400 kilometers takes 5 hours to complete, the rate of travel is 80 kilometers per hour. So notice that we're comparing kilometers to hours. When we have a ratio, we're comparing the same things. We would have kilometers to kilometers or hours to hours. So as soon as we take two things with different units and compare them, now we have a rate. A unit is a single quantity and associated with the number 1. 1 hour, 1 kilometer, 1 cent, and $1 are all unit values. So below is a table describing some properties that are measured in unit rates. So here we have another example of a unit rate, 80 kilometers per 1 hour. So rate, rate units, unit and symbol. So speed is given in kilometers per hour. So those are the two units that we use. The unit is per 1 hour and it's denoted as kilometers per hour, km/h. Food energy is how much calories per cup. So the unit is 1 cup and it's calories per cup, cal per cup. Fuel efficiently is liters per kilometer. So the unit is 1 kilometer and it's denoted as liters, capital L, per kilometer, km. Revenue is dollars per ticket or dollars per hour, depending on whether you're working per hour or you're selling something. So the unit is either 1 ticket or 1 hour, and it's dollars per ticket or dollars per hour, depending on the situation. And finally, the best buy, you want to look at grams per dollar or items per dollar, again, depending on the situation. But the unit is always $1. We want to know how much do we get for $1. And the symbol is grams per dollar or items per dollar. So then if we look at, well, how is a rate different from a ratio? A ratio compares similar things or similar units, height to height, volume to volume, milliliters to milliliters, etc. A rate compares things that have different units. Speed is distance and time. Distances can be in kilometers, time can be in hours. So we're changing units in our comparison. So 320 kilometers in 4 hours would be a rate because I'm comparing kilometers to hours. Unit rates are rates when one of the terms has been reduced to 1. So 320 kilometers in 4 hours is the same as 80 kilometers in 1 hour. So example 1, express each of the following as a unit rate. Round all answers to the nearest hundredth or 2 decimal places and state the units for each answer. So the first one is 302 kilometers in 2 hours. So what we do is we divide. We take the kilometers and we're going to divide by the hours because we want kilometers per hour. So it equals 151 kilometers per hour. $5.99 for 24 cans of pop. We want to take $5.99 and divide it by 24 because we want dollars per can. How much does each one cost us? So and it equals approximately 25 cents per can or 0.25 of a dollar because when we do this dividing and we round, we get about 25 cents. $30 for 5 hours of work. We take our dollars and divide by hours to get $6 per hour. 408 pages in 9 days. We take our pages and divide by days and get approximately 45.3 pages per day when we do the division on our calculator. 25 millimeters of rain in 4 hours. We take the millimeters and divide by 4 to get 6.25 millimeters per hour. The next example, example 2. Determine the better buy for each of the following by calculating and comparing the unit rates. So $442 buys 900 minutes, or $47 buys 100 minutes. Which is the better buy? Which one is cheapest over the long run? So what we're going to do is compare both of them by taking them to their unit rates. So I take $442 and divide by 900 minutes to get about 49 cents per minute, or 0.49 of a dollar. I do the same thing over here, $47 divided by 100 minutes, and I get about 47 cents, or 0.47 of a dollar per minute. So now we can see that this one, 0.47, is less than or lower than 0.49. So the better buy is the $47 for 100 minutes. So sometimes bigger is not always better. $5 for 12 cans of pop, or $27 for 60 cans of pop. $5 divided by 12 cans is about 42 cents a can, or 0.42 of a dollar. $27 divided by 60 cans, I do the division, get about 45 cents a can, or 0.45 of a dollar. The 0.42 per can is less, so the better buy is $5 for 12 cans of pop. $61.44 for 32 batteries, or $7.20 for 4 batteries. So take a second to do the math yourself and see which one in this case is a better buy.